show that the vector field f is conservative, then find a potential function f. That is, find f is a function of x, y such that gradient of f is this vector field. Note that the domain of this vector field f is R2, okay, whole R2, and open and simply connected region. So here we got two components, so that's is P and Q. Okay, so here P is sine y minus y sine x, and Q is cosine x plus x cosine y minus y. To check if this field is a conservative, all we have to do is find partial derivative of P with respect to y and partial derivative of Q with respect to x. If they are same, this field is a conservative field. Now derivative of P with respect to x sine y is, derivative of partial derivative of P with respect to y sine y is cosine y, derivative of sine y is cosine y, minus sine x bf's like constant with respect to y, and derivative of y is 1, so just sine x. Similarly, partial of partial of q with respect to x, cosine x is negative sine x, derivative of cosine x is negative sine x, plus cosine y behaves like constant, and this 1, this cosine y, minus derivative of y is 0 with respect to x, because this behaves like a constant. Oh, they are flipped, but they are still same, because cosine y plus cosine y minus sine x, so same. That means the vector field is conservative. Okay, then we can find a function of two variables such that partial of f with respect to x will be first component and partial of f with respect to y is second component. As soon as we check if the field is conservative, now forget about this. Okay, there exists a function f such that partial of f with respect to x is sine y minus y sine x, and partial with respect to y is the second component, which is cosine x plus x cosine y minus y, and equation 1, equation 2, and we are trying to recover the function f. Now we can integrate 1 with respect to x or integrate 2 with respect to y. It's up to you. Looks like equation 1 is simpler, so integrate 1 with respect to x. So we are keeping y as a constant. So when we integrate, then we just have function f as a function of xy. By the way, I'm just not writing parentheses xy is equal to antiderivative with respect to x. So sine y is like constant. Okay, when we have constant and difference integrate with respect to x, that's constant times x. So sine y times x, I'm writing here, minus antiderivative with respect to x, y is constant, and antiderivative of sine is negative cosine. So negative is minus plus cosine, and some constant of integration. So it will be a pure constant, or it could be a function of y as well, because we are integrating with respect to x. In this case, y could be a constant, so some function of y. This is integrating constant, okay, and could be a number or a function of y. Equation 3, and this would have been the answer, but we need to determine h. Okay, for look at equation 2. We have parcel of f with respect to y, and this is simply f. So let's find parcel of f with respect to y. So f with respect to y, and compare with 2. By doing so, hopefully we'll find the value of h, and come back here and write down the function, potential function. So differentiate 3 with respect to y. Fy is equal to x constant, derivative of sine y is cosine y, plus cosine x constant, derivative of y is 1 times cosine x, plus derivative of h is a single variable, just one variable, so it's prime. Okay, when we have only one variable, the partial derivative is same as regular derivative. Equation 4. Now compare 2 and 4. The left hand sides are the same. Cosine x same. X cosine y same. That means negative y should be equal to h prime of y. Okay. Compare 2 and 4. We get h prime of y equals negative y. Okay, our function, potential function, yeah, it was given here. Okay, h was missing. Now we will be able to find from here. Now h prime y equals negative y. Integrate both sides with respect to y. Integrate means h. So antiderivative of negative is negative. Antiderivative of y is y square over 2 plus some constant, and since we are looking for a potential function, we can take c0. Okay, looking for a potential function, so 0. Then h of y is negative y square over 2. Go back here in 3 and write down the final answer. Thus, a potential function is f is a function of two variables, x sine y plus y cosine x plus h of y is negative y square over 2, half y squared. Final